Hi, so we're ready to finish our problem number 4 on limiting reactant worksheet number 1. I noticed on the first video some of this got cut off a little bit, but we talked through what we did, so hopefully you can see it okay. So now we're actually going to do our molar conversions. We're going to convert both of our reactants into products and see which one of them makes less. That's our limiting reactant. Okay, so I'm going to do the one I start with first. So 0.25 grams CuCl2. That's what I'm starting with. Step 1, change grams to moles. Using my molar mass, I found that there are 134 grams CuCl2 in 1 mole CuCl2. Okay. Then I use my mole ratio, so I'm going to change CuCl2. I have 1 mole in my balanced chemical equation. And for every 1 mole, I get 1 mole of copper iodine, which is what I'm looking for. Sometimes students want to skip this step because it's 1 mole and 1 mole. It will cancel out. It won't really matter, but I want you to write it because it's not always that way, and that helps you solidify what you're doing. My last step, change moles to grams. 1 mole CuI2. And we figured out its mass over here, 318 grams CuI2. Okay, so let's cancel my units, make sure I did things right. Grams of copper, moles, CuCl2, moles of iodine. On my calculator, 0.25 divided by 134, multiplied by 1, divided by 1, multiplied by 318. That should give you an answer of 0.59 grams of CuI2. That's how much is made when I have 25 grams of CuCl2. I have to compare that to when I start with 0.64 grams of potassium iodine now. Okay, 0.64 grams Ki. Molar mass, this time I use 167 grams for 1 mole. And yes, I want you to write what the substance is as you go. It helps you keep track of things. Again, my mole ratio, this time it's for potassium iodine, so I have 2 moles potassium iodine because I have moles of potassium iodine on top. That's what goes on the bottom, so I can cancel it out. And then the next part of the equation is the same because I'm going to change it into copper iodine again. So 1 mole CuI2, my ratio, and then I do my molar mass. 1 mole CuI2 is 318 grams. Grams cancel, moles cancel, moles cancel. That means I'm left with grams of CuI2, which is what I want. This should give me 0.61 grams CuI2. Okay. Now I need to look at these, which one made less, because I can't make more than the one that stops when I run out. So this is how many grams of copper iodine I can really make. That means that copper 2 chloride was my limiting reactant. CuCl2 is my limiting reactant because it's the one that ran out first. Okay, so which is in excess? Now I'm going to take how much I could really make, which we found was 0.59 grams. So my given here is 0.59 0.59 grams of copper iodine. And I want to change it into my excess reactant. So now I'm going to change it into potassium iodine. I want to change it into grams of potassium iodine so I can compare it. Okay, so same situation, 0.59 grams CuI. Molar mass CuI. I did all these before. It's nice I don't have to redo my math. Still my mole ratio, 1 mole CuI. Oh, I'm sorry. These should all have a 2. And then 2 moles of what I'm changing it into, which is Ki. And then molar mass, 1 mole of Ki has 167 grams of Ki. And you'll notice this is kind of the backwards of what we did in part A. We're just working backwards. So I do my math. I found out I needed 0.62 grams of potassium iodine. Now the question asks how many grams will be left over. So if this is how much I really needed, I take how much I started with, which was 0.64 grams, and I subtract how much I needed, 0.62 grams. That should give me an answer of 0.02 grams potassium iodine were excess or left over. I hope that helps.